Okay, so in this video I'm going to solve question number 11, and so this is the exam review problems. Find the vector RAB magnitude and the directional vector RAB hat from the point A23 and B53. So we're given 2 points in space. So we're given 2 points in space. I won't bother putting the exact coordinates, but so 11 says you're given 2, 3, and 5, and negative 3. So 2, 3 roughly is about here. So let's put this as 2, 3. Just get a rough idea. Don't go crazy and try to be exact. This is a rough sketch of the problem. And the other point is at 5 and negative 3. So 5, negative 3 is B. So it's below. So here is our x-axis, here's our y-axis. So up is the j direction, and going across is the I direction. These are the directional vectors. So we have to construct the vector, the directional vector from the point A to point B. So we have to calculate this vector, and this vector is from the arrow drawn from A to B. So remember, this is the vector R, A, and B. Okay, so we know that the position vector of RAB is the difference between the position vector of B, the difference between RAB is the difference between RB vector minus RA vector. So this is the arrow drawn from A to B. Okay, so my notation in my notes is like from A drawn to B. So the position vector RB is this vector from here. How do you get to our B point? We travel 5 meters in the x direction and 3 meters down. So this is really 5I minus 3j subtracted by RA, which is 2I plus 3j. So how do I get to this point AB? I travel 2 meters in the I direction and 3 meters up to get to this. Or you can actually go and 3 meters up and 2 meters to cross. But now we just go in the I direction. So this is I has a value of 5 minus 2. And the j direction is minus 3 minus 3. Which in this case happens to be I has a value of 3. And there's a j component, which is minus 6. So this is the RAB vector. So the directional vector, so remember, directional vector is a pointing direction. So usually in mathematics and a lot of physicists say it's a unit vector, which is not the important idea. The important idea is that it's actually pointing in a certain direction that we can use as a directional vector, much like I hat and j hat. So I'm trying to calculate the directional vector, and I'm going to use the directional vector as a hat. So I got to get used to the arrows is just a vector, but if you want to say a directional vector, we're going to use a little hat. And that's equal to RAB arrow divisible by the magnitude of RAB. So in this case, it's going to be 3I minus 6j for RAB, and the magnitude of this vector is the square root of the sum of the squares, so 3 squared plus 6 squared. So we can translate that into 3, and I usually wouldn't do this, but 9 plus 36 is 45, so this is the square root of 45. We're not in a math class, okay, so don't try to reduce this and go crazy. We're not in a math class. We're basically scientists trying to solve problems as practically as possible. So 36 plus 9 is 45, so square root of 45. Okay, and so this is the directional vector. And if you actually think about it, the directional vector, the magnitude is a unit vector. That's not the point of directional vectors. Directional vectors, they are unit vectors, but you can use them to point in certain directions. And that's why they're important. We use them in electromagnetics and gravitational fields and magnetic fields to point in directions. So that's the point. Okay, so this was question number 11.